Okay, so remember to watch the theory first, and the formulas are a review after the test. So let's start with the notes, and let's take the point 3, 2. And let's just say y is equal to f of x, and it's simply just 1 point on the graph. So 3, 2 is on f of x. Now, what if I take that function, y equals f of x, and I substitute y minus 2 in for y, and then I simply add 2 to both sides of the equation? Well, I know that if I substitute y minus 2 in for y, well, then I remember that if I substitute the opposite operation for the variable and put y minus 2 in for y, that is a vertical translation equaling positive 2. And if I have the point 3, 2, then I do a vertical translation up 2 and simply take the y value and add 2 to it, because I substituted the opposite operation for the variable. So if I'm going to add 2 to the y value, my new value is 3, 4. And my point went from the old point on the graph, and it went up 2 to our new point 3, 4. Again, watch the theory. Think through it. Think about what happens to graphs if we have a plus 2 over there. Well, that means that we go up 2, and we've seen that in grade 10, y equals mx plus b, and we've seen that in quadratics, y equals x squared. So now just moving into grade 12, getting a little bit more familiar and comfortable with function notation, but understanding the theory. If I want to make a graph go up 2, I simply substitute y minus 2 in for y, and that will make my point go up 2. So what if I take the equation y equals f of x, and I say y equals f of x plus 2? Well, again, in the theory, we learn that if I take x and I substitute x plus 2 in for x, well, that is the opposite operation. So we will be subtracting 2 from all the x values, doing a horizontal translation equaling negative 2. Taking the old point, 3, 2, excuse me, I'm trying to make this incredibly perfect with respect to tables, and that's how we should be doing it every time. Writing the point down off to the left, exactly writing what we want to do, and then doing it. So if I want to do a horizontal translation to the left 2, it means I'm going to be taking the x values and subtracting 2 from them, and 3 minus 2 is 1, and the y value stays. So again, notice how tabular it is. The point is underlined. We do exactly what we're going to do to the point in short form, and it is incredibly tabular after. We want to keep this perfect because we're going to be doing multiple points, or we're going to be doing multiple things. So again, substituting x plus 2 in for x is a horizontal translation left 2. Feel free to take further looking at the notes, either printing off the notes or having 2 windows open side by side. And you can see all of the English instructions. Subtract 2 from all the x values if we substitute x plus 2 in for x. So let's see what that would do on the point to the graph. So remember, we started at the point 3, 2, and now we want to do a horizontal translation left 2, which means that we're now at the point 1, 2, as we figured out just a second ago. So simply substituting the opposite operation for the variable and understanding if any algebra is necessary in the equation above, or just simply saying what happened to the graph, or seeing something that's happened to the graph and having to substitute into the equation. So all throughout the notes, we're going to be going in both directions, but please make sure for this chapter to read the theory. There isn't theory on any other chapter except Chapter 7, Finance. Really understand the theory. Explain it to someone. Go over it with a friend. Understand the basics, because we want to learn one method, and that's substitute the opposite operation for the variable and know that that will do the opposite thing that we set it or substituted to do. So if we substitute y minus 2 in for y, that means that we're going to go up 2, and if we want to substitute x plus 2 in for x, that means we're going to go left 2. Feel free to look further in the notes, and we have another example on doing an example where we go right 1 and down 1, and always take a look at all of the English instructions over the page. So I'm going to now read 3 English instructions from the bottom. Do exactly what you see outside of the brackets on the right hand side to the y value. So this plus 2 over here, we actually make the y values go up 2. I'm going to read the sentence again. Do exactly what you see outside of the brackets on the right-hand side to the y value. And that makes the y values do a vertical translation up 2. Now the second sentence says, do the opposite of what you see inside of the bracket to the x value attached to the variable. So if I see x plus 2 inside of the brackets, then I know to go left 2, a horizontal translation, left 2, doing the opposite of what you see inside of the brackets to the x value attached to the variable. Now, remember, if the minus 2 is on the left-hand side, do the opposite of what you see on the left-hand side to the y value attached to the variable. And if you want to do algebra to get it onto the right hand side, if that is where you like it and that is where you understand it better, absolutely, but don't forget about where it came from, because if you like poetry, and I hope you do if you like math, I understand the 2 second sentences much better than I do the first and the second. Again, do exactly what you see outside of the brackets on the right hand side to the y value. But much more poetic, do the opposite of what you see inside the brackets to the x value attached to the variable. Do the opposite of what you see on the left hand side of the y value attached to the variable. Each and every one of these sentences is at the bottom of the following few pages in the first parts of each of the next sections. I will not be going into those sentences as much, but you will see how I'm going to want to do things foundationally. And if you pick up on it really quickly and see where things go and understand where they came from, I salute you. But I would prefer you do things foundationally until at least first or second year university, when you really start to understand it more. So let's take the function f of x equals x squared. And let's ask ourselves, what's f of 3 equal to? Well, it looks like I put 3 in for x on the left-hand side of the equation. So that means I have to put 3 in for x on the right-hand side equation. So f of 3 would therefore equal 9. We want to remember that we put whatever f of whatever it is, f of 3, we just put whatever that thing is into the right-hand side for x and then do whatever is necessary. So what we did was we just found the point on the graph 3, 9. F of 3 is equal to 9. In the notes, we have more simple examples with y equals x squared and putting 3 in and really reminding you that it's just making a table of values, and putting 3 in for x and it equaling 9, but we'd much rather do it with shorthand with y equals f of x, or f of x notation, function notation, f of x equals x squared. So now let's take that same equation, f of x is equal to x squared, and I want to know what f of x plus 2 is. Well, we learned that if we take x and we substitute x plus 2 in for x in the theory in the last section, that means that we simply put x plus 2 in for x, and we know that that is a horizontal translation equaling -2, the opposite. From quadratics, we remember that x plus 2 all squared shifts the parabola to the left 2. So substituting x plus 2 in for f of x, that means that it is a horizontal translation left 2, or -2. Now let's take the function f of x again. So f of x equals x squared, and let's say that f of x plus 1. Well, what's f of x plus 1? Well, we know that f of x is equal to x squared, so f of x plus 1 would just be that, what f of x is, plus 1. Now, that is a vertical expansion up 1, vertical translation up 1, vertical translation equaling +1. Now, what about all that theory that we talked about with the y equals, and how did the plus 1 show up where it did? Well, this is f of x equals x squared, and this is f of x plus 1. Well, let's do it in variable notation and say y equals x squared. And how do we get that plus 1 off to the right? Well, remember, we take y, and if we want to make it go up 1, we simply substitute y minus 1 in for y. So I take y and I put y minus 1 in for y, simply substituting the opposite operation for the variable. Then I can add 1 to both sides, and I have my equation y equals x squared plus 1, a vertical translation equaling +1. So be very comfortable with function notation and variable notation, how they're extremely similar. But usually variable notation is easier for students to work with. So if you like to simply substitute f of x, y in for f of x to more easily work with the equation, I highly suggest it. A couple notes at the bottom. Of the notes, again, print off the notes, making sure that you have the notes open and you at least are either watching through the notes or copying everything down and using the notes as a backup, but you'll never be able to keep up with all the English instructions, so I'm just going to read them off the page. At the bottom of the page, f of x does not mean f times x. F of x is one thing. We don't divide by any part of f of x or f of number, and we can't distribute into or factor out of a function. Y is a variable. F is a function. Y can equal f of x. Y can equal m of x. Y can equal g of x. And g of x is not necessarily equal to f of x or m of x unless they actually do. So remember, we started off this page in grade 10, substituting 3 in for x, and then started working with substituting in for variables. So the last section, or the last page of the last video, we looked at moving points around. Now we looked at working with equations. Now we're going to move on to graphs. Okay, so now let's take a look at a graph, y equals x squared again. So if I draw that graph from grade 11, I know that 0 squared is 0, and 1 and -1 squared is 1, and 2 and -2 squared is 4. And I can draw that parabola x squared. Now, what if I want to do a vertical translation equaling +1? a vertical translation up 1? Well, I remember that I always substitute the opposite operation for the variable, and if I want to go up 1, I have to substitute the opposite, y minus 1, in for y. So I do that in the equation, and notice I do it on exactly the same line where I said I was going to do it. And then I can simply add 1 to both sides of the equation if I like. Y equals x squared plus 1. And we know that that shifts the graph a vertical translation up 1. So each of those individual points are all going to have 1 added to their y value, and we get the new graph of the new parabola y equals x squared plus 1. As we saw in grade 11, that positive 1 shifts the graph up 1, but we have to absolutely remember where it came from, because if we remember to substitute the opposite operation for the variable, as we discussed in theory in the previous sections, we'll only have to remember how to do one method rather than very many. So, as you can see in the notes, we have a graph with a table of values and a different graph with the graph shifted up 1 with the new table of values and all the English instructions to add 1 to the y value or put y minus 1 in for y, substituting the opposite operation for the variable. And feel free to call it a new function. We may have called the first function f of x. Let's call the new function g of x, just for fun. So now let's take the function y equals the square root of x. So not as many people are as familiar with the square root of x, but again, let's do a table of values in our heads. So the square root of 0 is 0, and the square root of 1 is 1, and the square root of 4 is 2. So we have our sideways looking parabola. Again, feel free to check out the notes and see the table of values. Now let's do a horizontal translation equaling -1. So we want to make the graph go to the left 1. And I remember from the previous theory and sections that we always substitute the opposite operation for the variable. So if we want to go left 1 and we want to subtract 1 from all the x values, we're simply going to take x and substitute the opposite operation for the variable, x plus 1. So we can take the function y equals and substitute x with x plus 1. Our new function, which is a horizontal translation, left 1. So we can take all of the points and subtract 1 from all of the x values and move the graph to the left 1, and there is our new graph. Remember, substitute the opposite operation for the variable. If I substitute x plus 1 in for x, that means that I want to go left 1. We've seen this in quadratics in grade 11 where we did the opposite of what was inside the brackets and the same thing as the right-hand side of the brackets. But remember, if it's attached to the variable, do the opposite of what it says to do. Only with y, if it's off to the right, do exactly what it says to do to the y value, if you remember the English instructions from the earlier in this video. So again, we're going to be going up and down and left and right, always substituting the opposite operation for the variable. Remember, they may give you an equation like y equals x squared, and they may tell you to do something. Or they may give you an equation like y equals the square root of x plus 1, and they may ask you what that does to the graph. Or they might give you a graph like y equals root x and say, here's the graph of y equals root x plus 1. What has happened? Or they might just say, here is the graph. And what is the new equation? All different ways we can ask these questions. Be aware of going back and forth, different ways in between them. Okay, so we've taken a look at moving points around and working with functions and working with graphs and their equations and function notation and variable notation. Now let's move some functions around. So let's take a graph, and remember, print off the notes, or have the notes, or print off the notes and copy, or any version of that you like. Could just watch the videos if you like. So let's call this y equals f of x. Now this function up here in black, call it whatever you want, but for the moment, let's say it's in the form y equals f of x, whatever f of x was down below, plus k. Well, I know that I'm moving this graph up 4, and I know that from grade 10 and 11. If I want to, I can just say y equals f of x plus 4, and that would be a fine answer. Feel free to do it properly and say y equals f of x and substitute y minus k in for y equaling f of x, and then add k to both sides and simply substitute y minus 4 equals f of x. A very valid equation. Sure, we could take that equation and we could add 4 to both sides and say f of x plus 4, but that's the same equation that we wrote before. So remembering, we can write it in both ways. If you feel comfortable with just lazily putting a number off to the right, feel free, but remember it's going to be more useful for you in the future to do things properly and substitute the opposite operation for the variable. So if I want to go up 4, I simply substitute y minus 4 in for y, and then feel free to add 4 to both sides if that's more familiar from previous years. So now let's take another look at a different graph. So again, remember, print off the notes so you don't have to copy all this down so quickly, but whoops, that one was going to be in red. Excuse me. I'm going to move this one to over where the black one was. So that one in red was here. Now let's call the red one y equals f of x again. And this time, let's move the graph to the right 5. So again, remember, we can have y equals f of x. And if I want to go right 5, I'm going to substitute the opposite operation for the variable. And I'm going to take x, and I'm going to put x minus 5 in for x. Y equals f of x minus 5. And remember, substituting the opposite operation for the variable moves the graph. Putting x minus 5 in for x is going to move the graph to the right 5. So again, in the above example, if you want to go up 4 and you just want to put a plus 4 off to the right, feel free. And if you want to do things properly and always substitute the opposite operation for the variable, then I highly suggest that if you want to go up 4, you put y minus 4 in for y, and then if you like, leave it like that, or add 4 to both sides, because if you do that, then it's simple. If I want to go up 4, I put y minus 4 in for y. If I want to go right 5, I put x minus 5 in for x, always substituting the opposite operation for the variable. But a lot of the times you're going to see numbers off to the right and you're going to have to know what they mean or where they came from. But when it's with respect to x, there is only one simpler notation and substitution for it. In the notes, we have an example of going down 3 and to the left 3 in both function notation and variable notation with all the proper substitutions, so please feel free to look over that. And remember, we're going to take these things onto bigger scale, so you really want to know the basics, understanding these most basic steps like substituting the opposite operation for the variable. And then when it gets more complicated, we just break it down into these little steps, and eventually it will be a lot simpler than trying to look at it as a whole.